I'm Anil Kumar, and here I am back with linear and quadratic systems. So these are three questions which you should add to your unit test preparation. Question number one is explain the number of solutions which two quadratic functions can have. Provide example to support your answer. So I've extended linear and quadratic systems to quadratic and quadratic systems since I'm talking about two quadratic functions at the same time. Now, I'd like you to carefully look into the example which I am dealing with. Let's read the question once again. Explain the number of solutions which two quadratic functions can have. Provide example to support your answer. So let's consider two quadratic functions and see how many different ways they can intersect. So when you're saying solutions, that means how do they intersect. So let's take one example like this. Let's say this is one quadratic function, and then we have another quadratic function which is kind of like this. Now let's take simplest of all the examples, and we'll only consider the parent function y equals to x squared. So here I have y equals to x squared moving upwards, and this one is for me y equals to minus x squared. As you can see, there is only one solution since they meet at x equals to 0, right? So the intersection here is 0, 0, and we have number of solutions is equals to 1, correct? Now let's consider another case, and this time what we will do is we'll drift 1 and we'll keep 1 stationary. So that means, let's say we have our parent function which is y equals to x squared. Let's keep it fixed here, and let's move around the other function. Now if I move it downwards like this, then what happens? Then you can see that this equation is minus x squared, and we moved it further 1 unit down, let us say, and now we have no solution, right? So that is no solution. Do you see that? Now we'll have one more situation, and what we will do this time is we'll move it upwards. So let's have it y equals to x squared right there, and that is kind of fixed for us, and we are moving this function slightly upwards. And if we do that, then what do we see? So that is minus x squared plus 1. We moved it upwards, and this is my original parent function x squared. So we have now two solutions. Do you see that? So we have two solutions. So at x equals to 1, now we can definitely find these two solutions, what the values are. So we have two solutions, and you can always find the solutions. That means the y values are same, and at this time we say x squared equals to minus x squared plus 1, or 2x squared equals to 1. So x is equals to half and square root plus and minus. So at x values of plus minus square root half, we have their point of intersection. Now if I put half there and square that, then you get your answer. So we have two solutions here, and in this particular case our solutions are 1 for square root of 1 over 2, I could write. The y value will be just half, right? And the other one is, we can write 1 over square root of 2 with a minus sign, but still the y value will be square of this, which is half. So these are two solutions. So we get number of solutions is now equals to 2. Do you see that? So we could get either one solution, no solution, or two solutions in this case. Now what happens if I move it further up? Well, the number of solutions don't really change, and it will intersect at two points, right? So these are the options when we are dealing with two quadratic functions, correct? So that is how we can explain with the help of an example, saying like how can they interact with one another. So we can now summarize our results, and that is the number of solutions could be, so number of solutions possible are either none, that means 0, or we have 1, or we could have two solutions, right? So in short, that is our answer for this particular question, right? So just as you saw with linear and quadratic system, if there is a linear, let's say, now we consider a linear system, for example, then a line can intersect, as you saw, in 2 points, or at one point when it's tangent, or at none points, right? So it's kind of similar in both the situation. Can you tell me the reason why the number of solutions with two quadratic functions and with a linear and quadratic system is kind of same? The reason lies in the fact that ultimately we are trying to solve one equation which is quadratic in nature. Do you understand? It's basically quadratic in nature, degree 2. So when you are solving equation of degree 2, so the reason is, since we are solving degree 2 equation, quadratic equation is degree 2, we expect two solutions, right? Now there are always two solutions. Sometimes both are not real, both could be imaginary. Sometimes both are real, and sometimes both are same, since we could have both points at the same point. Do you understand? So in short, that is how we are going to explain this particular concept. I hope that is very helpful and a new kind of information for some of you. I hope you appreciate it. And let's now look into linear and quadratic systems. Thank you and all the best.